All right, so when I talk about rewriting GLX, I'm talking about rewriting the X server's side of it. No, not this week. Not at the moment. The server side of the GLX does two things. It sort of is the GLX protocol for both for both direct and indirect contexts, to allow you to do things like create a context, make it query whether it's direct or not, query the list of visuals and FB configs and blah blah blah. And also in indirect contexts, it's the thing that actually does the rendering. It has a couple of big pile of generated code that eats GLX render protocol requests and thunks them through to something and turns that into GL and then actually completes the swap buffers and that kind of thing. So some of us eventually would like not to be running X as our primary Windows system, but we still have to maintain compatibility with X applications, GLX applications in particular, which means that this has to continue to work in the future. The easy way to do that, as Chris had sort of hinted at, is you have a DDX that doesn't know what a driver is anymore. It basically just talks to, say, Glamour or something else that's GL-like, and or straight to EGL, uses that to render. And then you no longer have to maintain an Intel driver and an NVIDIA driver and an ATI driver. You can if you like, but you don't need to special case them if you don't have to. The way that this code is currently implemented makes this really hideous, because we've got more than one GLX implementation at the moment. We actually have two. There's Xserver GLX, which works for most of the DDXs, and then there's one under HW DMX GLX Proxy, which is similar. The code looks very, very similar because it's all got the same genetic history. It all came from SGI code dumps at one point in its life or another. And GLX Proxy is a little bit sketchy because what it does, more or less, is... Yeah, it's a lot bit sketchy, as Keith says. It essentially takes the request in off the wire and smashes the XIDs around, and then takes the literal request and passes it to all of the back-end servers and hopes against hope that they all reply equally. So it's literally just repeating the protocol and not doing any sort of interpretation in the middle. Since these two things don't share any code, the DMX code is, well, fairly far behind. It's GLX 1.2 instead of 1.4 at the moment, which means you don't get P buffers, you don't get a bunch of other cool stuff. And basically every time I fix a bug in the core implementation, I don't fix it in DMX because you forget to. That's a lie. We have 4 GLX implementations. We have the one in GLX, in the top level GLX implementation, is not only used for X.Org and VFB and KDrive, Zephyr sort of, but it's also used in the Windows and Quartz backends, and they have to kind of massage the dispatch table to thunk down to their OS level GL implementations. So there's already several layers of funniness about, okay, well, each of these back-end Windows systems looks a little bit different. So it's difficult to modify or fix anything at the top level without worrying that I've broken the Windows or Quartz backends. That's a lie. We have 7 GLX implementations. The one for X.Org itself sort of has 3 backends: one for DRI1 drivers, and one for DRI2 drivers, and one for SWRAST drivers, of which we have 3 by this point in time. So that's all pretty awful too, because now I have to, this does the bindings to things like create the context, swap buffers, wait GL, wait X, and every single one of those has its own subtle dependencies. Things like when you do DRI2 drivers, wait X rendering actually implicitly calls out to say copy from the fake front buffer to the real front buffer. I think I have that order right. But there's all these details, so all of this matters. So depending on how you count, you have somewhere between 2 and 7 GLX implementations, and that's ignoring the direct rendering part of Zephyr. That doesn't really work if your host doesn't implement DRI1, which none of them do anymore because Mesa deleted the DRI1 drivers in Mesa 8, and thank you for doing so. The 3 that live under that work in the X.Org loader, that know how to load DRI1 and DRI2 and DRI software drivers, know what a DRI driver is. Rather than calling GL API functions directly, they know what the DRI dispatch table looks like, which is this big vector of function pointers that you smash around. It's the same thing that internally the DRI driver has to do whenever you switch from at GL begin and GL end, whenever you're switching into entering a display list mode and back out. That big list of function pointers, yeah, our X server knows how that's laid out, and we have broken that on occasion. And this really is an implementation detail of Mesa. It shouldn't be something that the X server knows about. And so it's hard to use GL internally. If you look at the code in Glamour for compatibility with X.Org, whenever you enter Glamour, it has to go back to the global API dispatch table and smash everything around to reestablish its own context, and not just because an indirect client may have interfered in the meantime. So it's really hideously ugly to do this thing. And again, this is really exposing a Mesa implementation detail that we had because when we implemented AI GLX, we didn't have EGL. We didn't have a way to talk to the GL underneath us sort of abstractly without needing to know what the driver was. The only thing we had was, well, we can load DRI drivers, and that's good enough. So it's all really just ugly. So this is what GLX Vertex 3F looks like at the dispatch. And what that's saying is, this, once you've come in with the GLX render request, we do this magic. This is all code generated, which is why it looks about as hideously indented as it is. And that's saying call GLVertex 3F, and you have to look up the dispatch table to do it, which varies depending on whether you've built with TLS support or without, because apparently some people like to break their machine if threading it in the presence of threads. No, it's actually uglier than that. This is what the implementation of that looks like, and again, this is all code generated, so when the implementation of call Vertex 3F is this big macro that emits this static thing that calls get by offset, and then get by offset is this hideous thing up here that knows about what the dispatch table looks like, and you generate piles of this for literally every GL entry point. I'd prefer not to. After the rewrite, it looks more like this. Way, way simpler. And PC here is the bits in the byte stream off the rendering request that say, here's the arguments to GLVertex 3F. Just have done it. Once you're done with that, the result is pretty cool. Just the mechanical change to get rid of that level of indirection blows away about 38,000 lines of code and massively shrinks your libglx, because now you're not generating all of these stub functions to do this redirection. Presumably performance could be better too, although if you're worried about indirect rendering performance, you've already lost. So, old world looks like this. These are all of our old backends. In the new world, AGL and EGL and GLX and WGL all kind of fold together, and they all look very, very similar, because it turns out all of those APIs look very similar for some reason. The Windows system binding is sort of uniform across most platforms, and there's not really a lot of variation. So it becomes a lot easier to kind of mechanically verify your changes and say, well, I'm changing the support for in the EGL backend, and I know that it's probably going to need something similar in the Wiggle backend. And actually, the Apple and Windows backends end up needing to synthesize that big GL dispatch table that Mesa drivers look like to thunk through to their own implementation of the host OS. So they have to fake being a DRI driver to call down to their libgl. That all goes away too, or will once I deleted it. The driver interface once again becomes a Mesa detail, which is super cool because, again, not only have we broken it accidentally in the past, but we would like to be able to break it in the future. It's something that libgl should be able to have as a sort of a private contract with the DRI driver. If you want to change how drivers are packaged, like, for instance, simply linking all of your Mesa drivers into one single shared object, because that lets you do things like link time optimization and cut 3% off of every function call. Also pretty cool. So that's great for future maintainability. Open issues. Again, as we as James kind of hinted at earlier, the EGL backend isn't entirely agnostic of what platform it's running on. You have to know something about what your EGL really is. If you're running on GBM or if you're running on Surface Flinger or whatever, you still have this little bit of side knowledge about how to create the native surface underneath you, and that leaks into how you store pix maps, which is sort of obvious. Like, you need to be able to say, I've created an X pix map, I'm going to make a GLX pix map set on top of that. In order to do that, you either need to somehow promote the pixmap contents into being GLX pixmap contents by just decorating them magically, or you need to copy the bits out, or you need to have created them up front so that they are simply compatible storage. And the way you do that is you ask for a handle from GBM. Well, you'd like not to do that. You'd like to just say, I don't want to know what EGL I'm running on top of, just give me a pixmap. Yeah, and I haven't actually done the bits where the Windows and Quartz and DMX proxy backend, GLX proxy backends are converted. They should be relatively straightforward. The hard part was getting all the auto-generated code to do the right thing. In fact, I've really only implemented it for XNest at the moment, and that's not what I said. XNest, on the other hand, is now fully self-hosting, so you can do GLX on GLX, and it does work. And I have a demo of that on this other laptop that is not plugged in. And again, like I say, for fixing this through in X.Org, you need to establish sort of a convention for how your driver allocates pix maps in a way that that will be compatible with indirect GL once it happens to go. Alternatively, we could just turn indirect GLX off and throw bad alloc if you ever try to allocate an indirect context, but I would consider that a regression, and so would my customers. To do this, you have to link libgl into the X server, and this is fine for GMX proxy, for DMX and Nest and Zephyr, because they're already X clients. And then on top, you also link again on top of that libcapitals GLX or libegl to know what backend you're talking to. So this could go away at some point. Right now, it's sort of distasteful that we have a client library loaded in the X server, but it would work. Also, this can't possibly work anymore. DRI1 drivers, after this rewrite, would have to go away. And in fact, since the DRI1, 2, and SW loaders all go away, the only client-side drivers that can work, the only DRI drivers that can work in terms of Mesa are the ones that have EGL support, and that's never actually worked for the DRI1 drivers because DRI1 has an S area, talks to the XF86 DRI protocol, expects that there's an X server that it's communicating with, and we could revive the old mini GLX code if we really wanted for this, but again, these are drivers that have been deleted for about 2 years now, so you would really no longer be able to run DRI1 support at all anymore. Ian, you look like you want to say something.
Yeah, so, I mean, we've also been kind of talking about in the hallway track about completely changing the way that dispatch works using ifuncs, and that would completely ruin interacting with DRI1 drivers too. So if we're going to have a flag day, let's have a flag day. Yeah, well, no. I mean, if you have one good reason to finally kill support for something, then you have a discussion about it. But if you have 2 good reasons, then why are we still discussing it?
Yeah.
So if we make this interface something that only the libgl or Mesa knows about, we don't even have to have a flag day, because the only reason to have a flag day is that X knows about it, and we want to make sure we don't break the API so X gets confused. But if this is now only something libgl or libegl or whatever,
your flag, it would be a flag day in the sense that if you changed the implementation in Mesa that you could in say Mesa 9.3, that you would no longer be able to use Mesa 9.3 against X Server 1.14. That if you're changing that loader interface, because that's
Right.
a server that knows
Yeah.
what
And
DRI drivers are.
I know Dave Alley's always been concerned about this case, and he said you don't want to break the DRI driver interface. And what comes up is that what if you have an old DRI driver from an older version of Mesa and a new version of Mesa, and then they will break? And I think that's the case. We can also just say that that's not going to work in it.
Hand him the thing. Thank you.
I think that we can make new Mesa work with old X server. I think we could frob stuff around and make that work, but I think what couldn't work is old Mesa with a new X server that does this, and that's what I'm saying.
I think
Let's
that's
just do
backwards, right? Because at this point, after this rewrite, I'm just talking to libgl. I don't care what your DRI interface is, and the only time.
Well, I mean DRI1 Mesa.
Oh,
It wouldn't work with that because of no EGL and because of
Right.
lulls.
yeah, your Savage 4 would no longer have accelerated and indirect rendering. I'm really sorry in two ways. So basically, again, we talked about this yesterday. This is sort of some open-ended work. So finishing the port of this to the hardware drivers and to the non-Unix DDXs is sort of the last proof of, okay, we need to get this working. So this is, can we get this done in the next month? Does this sound like something that's too big to take in the next month or so? Does it sound too revolutionary? Does this disrupt anybody's product plans for long-term support? It doesn't really disrupt mine. I don't really need anything newer than X Server 1.14 and RHEL releases that I have to do long-term maintenance on. So are there any objections? Are there any concerns? I've kind of blown through this relatively quickly, so if there's anything I need to repeat, let me know. Eric?
Are any distributions shipping the DRI1 drivers anymore?
RHEL 6 is. We actually we have two Mesa packages, and one of them builds the DRI1 drivers, and the other one only. And the other one builds libgl and everything else.
Okay, I wasn't sure if anybody actually did that. That's cool. Sort of.
And even that, with my enterprise support hat firmly off, those are best efforts anyway. I mean, the amount of attention that the Matrox and Savage drivers get in those OSs is, well, if it works, that's awesome. If not, they probably don't, and we've not really received bugs about it. So really, it's just not dropping drivers because we're not allowed to drop drivers in a stable release stream. So I would have to keep shipping X Server 1.14 for a while because I would have rewritten GL in a way that's incompatible with these DRI1 things, or I would simply move to X Server 1.15 and say, well, you're going to get a software renderer in indirect contexts from now on. Sorry about that.
You're only talking about software indirect not breaking direct
I wouldn't necessarily be breaking direct rendering with DRI1 drivers. If we were to leave DRI1 in the server as an implementation, if we chose to leave DRI1 present as an extension, it could still work. I don't especially feel like validating that. I'd have to find a Savage to do it. Mm-hmm. Yeah, indirect. It would be regressing to software RAST. It was only interesting when it was the only way to do compis. The assertion was that direct render DRI1 was the only thing that's interesting. Indirect render DRI1 accelerated is not that cool, and it's true. It's not that cool because that's the reason that was there was for AI GLX to get compis off the ground before we had GEM.
Just that short window of time between when we had accelerated
It does seem like a small window of time. It probably felt longer at the time because I had to watch Christian implement it, and it took a while. Yeah, we didn't have a memory manager for actually quite a while. It was probably Fedora 6 to 11 or something like that which is 2.5 years. But yeah, that's basically all I have. It's end of slides here. So if there's nothing else, I really just want to know cool or not. Depends on. No, you don't. It depends. If you built the DRI1 support in the server, then you get both the DRI1 AI GLX loader and the DRI1 client direct render protocol support. After the change, when you queried libegl, if you were to look at the driver strings that come out of libegl, it would depend on what your EGL had given you. Yes, you do, because EGL is how after this EGL, like the indirect renderer, works by itself creating an EGL context and asking that EGL context to provide a GL, right? So indirect rendering context comes into X server. It creates logically a direct EGL context. So the driver you get out of that would be whatever your EGL can come up with, and it would probably only be SWRAST because there is not DRI1 support for EGL. Yes, it should work with SWRAST. LLVM pipe's actually a bit better than GL 1.4, but yeah, it would be. Yeah, you would have a performance regression if you would almost certainly have a performance regression if that was the sort of thing where you were measuring it. But your direct rendered support could still work if you chose to continue building the direct rendering support for DRI1. There are people who apparently complain that we remove XAA. So it's no, I don't believe. I mean, our enterprise releases upgrading to X Server 1.15. I honestly haven't decided yet. If there's not, for me, speaking as Rel 6 maintainer, I don't care. Like, there's not anything so intrinsically valuable in 1.15 that I can't backport to my enterprise release. There are a couple of features that'd be nice, but I already know how to backport them. I can put them in a 1.14.4, 5.6 if they need to go upstream. I don't need 1.15 for Rel 6 or anything after. And in Rel 7, I don't have an ABI guarantee. I don't have a feature guarantee that I'm preserving. So, in that sense, I'll pick whatever's ready for Rel 7. But for Rel 6, which is the only one where I'm still doing regular X server updates, and I don't care at all. I can't speak for SUSE. I can't speak for Oracle. I can't speak for Canonical. But I don't know. I honestly I don't even know what their update strategy is for their releases in that sense. I would be entirely fine with dropping DRI1 entirely in 1.15. I would be fine with dropping it entirely in 1.12 or whenever it was that was contemporary with Mesa having dropped the drivers. It doesn't. There's not a lot that would clean up. There's not really internal interfaces that exist only for DRI1's benefit. But I also don't trust the DRI1 code, and I know that there are. Eventually, there do become things like it becomes difficult to add anything to the GL because then I also have to either to case out in the DRI1 code, make sure that I don't hit that path. If I want to add additional GLX extensions that require additional server support, I don't want to have to make sure that I'm paying attention to the DRI1 code at all. I would like not to know what a DRI driver is. I'd like to be able to phrase it entirely in terms of my EGL extensions. AI GLX DRI1. So, to repeat that for for posterity the idea of direct render DRI1 support and indirect render DRI1 support are separate issues, and that the direct rendered support is a separable thing, and there's not really any harm in allowing that to continue. Yeah, we can certainly kill it later. I'm happy with killing it as soon as possible, but there's no reason to be unnecessarily aggressive about it if it's not going to. It doesn't impede anything we're currently working on. And the fact that doing this means I don't need to write a DRI3 loader is also pretty cool. So that's it, I think. Any other questions? Cool, thanks. That depends on how much help I get. I have the patch series on my free desktop repository. I actually have an old version of that. I can push a newer one as soon as it goes down. And again, works for XNest. Has a skeleton of something that looks like it might work with Glamour, but assuredly does not. So the rest of the proof of concept of wiring that up in VFB, going down to GVM, and allocating your buffers that way, and wiring that up with a couple hardware drivers and making sure that they continue to work. That's what needs finished. But that's.
I'm not so worried about using GL in the server part.
Mm-hmm. Okay. So that's less than that's within a month, I think.